Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
There's always movement in the AI tooling space, and some interesting shifts are being observed, even subtle ones, from the major players. What are the initial observations?
Looking at OpenAI, particularly their codex efforts, there are indications of a refined focus. It's less about raw code completion at the granular level and more about assisting with higher-level architectural design and problem decomposition.
So, moving beyond just writing functions to helping engineers actually structure their solutions, that's a significant leap in ambition if they're pulling it off.
Exactly. It suggests a strategic move towards tackling more complex engineering challenges, potentially streamlining the initial design phases of software development rather than just accelerating coding speed.
And Anthropic with Claude Code, any notable developments there?
With Anthropic, the quiet improvement seems to be in Claude's code understanding, specifically its ability to parse and interpret legacy systems. Reports highlight increased accuracy in handling obscure syntax and providing more relevant refactoring suggestions for older code bases.
That's a very specific but incredibly valuable niche. Legacy code is a massive pain point for many organizations.
It really is. This suggests Anthropic is strategically targeting large enterprise clients burdened with complex existing code bases, where deep contextual understanding is paramount for modernization and maintenance. It's a pragmatic play.
Google's Gemini has been widely integrated. What's the word on its coding capabilities this week?
Google appears to be integrating Gemini's code capabilities even deeper into its broader cloud development ecosystem. The push is towards tighter coupling with services like Cloud Run and Kubernetes, making it more intrinsically part of their platform.
So, for developers already using Google Cloud, Gemini becomes an even more seamless, almost ambient assistant.
Precisely. The strategy seems to be about reducing friction for developers already invested in their stack, leveraging Gemini's strengths across the entire Google Cloud platform to enhance productivity from within.
GitHub Copilot remains a staple for many. What's new on that front?
Microsoft seems to be placing a strong emphasis on Copilot's enterprise features. The focus is increasingly on customizability and integration with internal knowledge bases and proprietary code repositories.
So, moving beyond a general-purpose coding assistant to something that's truly tailored to an organization's specific coding standards and unique libraries?
That's the direction. It's about transforming Copilot into a highly specialized internal development resource, which could significantly boost development velocity for large teams by ensuring consistency and leveraging institutional knowledge.
And Cursor, often at the forefront of AI-native IDEs?
Cursor is reportedly enhancing its multi-file understanding capabilities. The goal is for the AI to reason across an entire project's context, not just the currently active file or a small snippet.
That's a substantial challenge, given how complex code bases can be. But if they can do it, that's a massive leap for tasks like complex refactoring or debugging.
It absolutely is. It addresses a major pain point where current AI assistants often struggle with maintaining a global understanding of a project. Improving this could make Cursor even more powerful for large-scale development and architectural changes.
Any new players or frameworks catching attention?
There's some early buzz around a framework provisionally named Windsurf. It's being touted for a novel approach to generating boilerplate code for web applications, with a strong emphasis on baking in security and performance best practices from the outset.
A focus on security right from the initial code generation is intriguing, given how often security is an afterthought.
Absolutely. If it delivers on its promise, it could establish a new standard for early-stage development, ensuring that foundational code is robust and secure from day one, which is a significant value proposition.
That's a solid roundup of the latest shifts. These themes of control, customization, and moving beyond monolithic models are highly relevant to our main topic today.
Indeed. It's about a quiet but profound shift in how people interact with and build upon large language models.
Let's turn to a concept that's been dubbed the harness. The title for today's discussion is Unlocking the Black Box: Why the Harness is Quietly Killing the LLM Monopoly. That's a bold claim. To begin with the black box aspect, why is the black box nature of LLMs such a persistent problem for developers and researchers?
The black box problem refers to the inherent opaqueness of large, complex models. You feed them input, they produce output, but the internal reasoning process, the specific weights and biases that lead to a particular decision, remain largely obscure. For developers, this creates significant challenges in debugging, understanding failure modes, and ensuring reliability. It's difficult to troubleshoot something when you don't know why it did what it did.
So it's not just a philosophical concern. It has real-world implications for building robust applications.
Exactly. Consider a medical diagnosis system or an autonomous vehicle. If an LLM makes a critical error, simply knowing that it erred isn't enough. You need to understand the causal chain, the specific data points or internal states that led to that misstep to prevent recurrence. Without that interpretability, trust and widespread adoption in critical applications become difficult. It also makes it harder to identify and mitigate biases.
That makes perfect sense. So, the harness is presented as a solution to this. How is the harness defined in this context? What is it conceptually?
Conceptually, the harness isn't a single tool or a specific model, but rather an emerging philosophy and a set of interconnected methodologies and frameworks. It's about gaining more granular control and transparency over LLMs, effectively pulling back the curtain on their inner workings and guiding their behavior with greater precision. Think of it as developing sophisticated steering mechanisms and diagnostic tools for these powerful but often unwieldy models.
So it's less about building a better LLM from scratch and more about building better around existing LLMs.
Precisely. It's about shifting the focus from simply consuming an LLM's output to actively shaping its reasoning process and understanding its internal state. This can involve everything from advanced prompt engineering techniques and sophisticated orchestration layers to novel fine-tuning strategies and robust evaluation frameworks.
That makes perfect sense. So it's less about building a better LLM from scratch and more about building better around existing LLMs.
Precisely. It's about shifting the focus from simply consuming an LLM's output to actively shaping its reasoning process and understanding its internal state. This can involve everything from advanced prompt engineering techniques and sophisticated orchestration layers to novel fine-tuning strategies and robust evaluation frameworks.
Advanced prompt engineering has been observed to evolve from simple instructions to complex few-shot examples and chain-of-thought prompting. Is the harness taking that to another level?
Absolutely. It moves beyond mere instruction giving to creating dynamic, adaptive prompting environments. Imagine a system that not only crafts initial prompts, but also monitors the LLM's intermediate outputs, identifies potential ambiguities or misinterpretations, and then iteratively refines the prompt or provides corrective guidance in real time. It's about building an intelligent dialogue with the model to guide its internal thought process.
That sounds like a meta layer, almost like a separate AI agent interacting with the LLM.
It often is. Many harness approaches involve creating an outer loop of control logic, where smaller, specialized models or rule-based systems observe, analyze, and direct the larger LLM. This modularity is a key characteristic. Instead of relying on one gigantic model to do everything, you break down complex tasks into smaller, more manageable subproblems, each addressed by the most suitable component.
And how does this modularity contribute to unlocking the black box?
By breaking down the task, you create more checkpoints and smaller, more understandable steps. If a larger LLM is performing a multi-step reasoning task, the harness can interject at each step, asking the LLM to explain its current rationale, validating intermediate results, or even correcting its course. This exposes the LLM's reasoning process in a way that wasn't possible when it was just a single end-to-end black box. It's like having a supervisor observe each stage of an apprentice's work rather than just seeing the final product.
That's a powerful analogy. This sounds like it could dramatically improve reliability and auditability.
That's the core promise. It moves beyond simply hoping the LLM gets it right to actively ensuring it follows a desired logical path. This dramatically increases the ability to debug, to identify biases early in the reasoning chain, and to provide clearer justifications for outputs.
So how does this harness then kill the LLM monopoly? What's the connection between interpretability and breaking up the dominance of a few large models?
The connection is multifaceted. Firstly, by enabling more precise control and better interpretability, the harness allows developers to get more out of smaller or open-source models. If you can steer a moderately sized model with sophisticated prompting and orchestration, its performance for specific tasks can approach or even exceed that of a much larger general-purpose proprietary model.
So it's about reducing the premium on sheer model size and proprietary training data?
Exactly. Historically, to get better performance, the mantra was bigger model, more data. But with the harness, you can achieve comparable results by being smarter about how you use a more accessible model. This democratizes access to high-performance AI. If you can fine-tune a smaller open-source model and then effectively harness it, you no longer need to rely solely on the APIs of the large, expensive proprietary models from the likes of OpenAI, Anthropic, or Google.
This sounds like it empowers innovation outside the major AI labs.
It does. It shifts power from the model providers to the system builders. The value moves from owning the largest, most powerful foundational model to owning the most effective harness, the best system for orchestrating, guiding, and evaluating LLMs. This means smaller companies, open-source communities, and even individual developers can build highly competitive AI applications without needing multi-billion-dollar compute budgets.
So it's less about a single general intelligence and more about specialized, well-orchestrated intelligences.
You've hit on a crucial point. It shifts the fundamental approach from a model-centric view of AI to a system-centric one. The intelligence isn't solely resident in the base LLM. It's in the entire architecture that surrounds it, the way tasks are decomposed, information is retrieved, and outputs are validated and refined. This makes the LLM just one powerful component within a larger, more controllable intelligence system.
For developers, what are the practical implications? Does this mean they need to become experts in complex new frameworks, or does the harness simplify their work?
In the short term, it might introduce a new layer of complexity as developers learn to build and manage these orchestration layers. However, the long-term vision is simplification through abstraction. Just as frameworks like React or Kubernetes abstract away underlying complexity, the harness aims to provide intuitive ways to define task flows, set guardrails, and implement validation steps for LLMs. It means more control, less magical thinking about AI behavior.
So engineers get to be more like conductors of an orchestra, rather than just passively listening to a single, unpredictable instrument.
Precisely. They become composers and conductors of AI systems. They're empowered to inject domain-specific knowledge, integrate proprietary data sources, and enforce business logic more effectively. This dramatically reduces the uncanny valley problem, where LLMs sometimes produce plausible but fundamentally incorrect or inappropriate responses because they lack specific context or guardrails.
What are some of the technical underpinnings that enable the harness? Is it about better agents, specific architectural patterns, or new types of programming languages for AI?
It's a combination. Agentic frameworks play a significant role, allowing the LLM to interact with tools, retrieve information, and execute code in a controlled environment. Architectural patterns like Retrieval-Augmented Generation, or RAG, are key, providing models with external, verifiable information sources. There is also a rise in specialized AI programming languages, or declarative frameworks, that allow developers to specify desired behaviors and constraints, rather than just providing raw prompts. Think of it as moving from natural language instruction to structured, programmable guidance for the AI.
And how does this impact the ability to manage costs? Large LLM API calls can get expensive.
That's a critical factor. By intelligently decomposing tasks, the harness allows developers to route different parts of a problem to the most cost-effective model. A complex reasoning step might go to a powerful but expensive proprietary LLM, while simpler summarization or translation tasks could be handled by a smaller, cheaper open-source model, or even a local fine-tuned model. This dynamic routing optimizes both performance and cost. It's about not using a sledgehammer for every nail.
That sounds like a powerful argument for enterprises looking to scale their AI adoption. But what are the challenges in building and deploying the harness? It can't be entirely straightforward.
Absolutely not. One major challenge is the inherent complexity of designing robust orchestration logic. Managing multi-step reasoning, error handling across different models, and ensuring seamless integration with existing systems requires significant engineering effort. Another is the ongoing evaluation problem. How do you definitively know your harness is guiding the LLM correctly and improving performance, especially with rapidly evolving base models? It requires sophisticated monitoring and continuous validation.
So while it addresses the black box problem of LLMs, it can introduce a new layer of complexity in the system design itself.
Exactly. The black box doesn't disappear, it just gets pushed up a level. Now, instead of one giant black box, you have a black box LLM within a larger, potentially complex harness system. The goal, however, is that this outer harness system is designed to be transparent, auditable, and controllable, offering a better trade-off.
Looking ahead, what does this mean for the competitive landscape of AI in the next few years? If the harness gains traction, does it truly decentralize power, or will a new set of harness monopolists emerge?
It certainly has the potential to decentralize power, but a new competitive front is likely to emerge. Instead of a monopoly on models, intense competition might be seen around the best harness frameworks and the best AI system integrators. Companies that can offer superior tools for orchestration, evaluation, and fine-tuning will become incredibly valuable. The focus will shift from who has the biggest model to who can build the most effective, transparent, and cost-efficient intelligence systems using models.
So, the battleground shifts from raw compute and foundation model dominance to intelligence orchestration and system design.
Precisely. This is why increased investment is being observed in areas like agentic frameworks, sophisticated prompt management platforms, and MLOps tools specifically tailored for LLM deployment and monitoring. The industry is recognizing that the future isn't just about powerful models, but about empowering developers to wield those models effectively and responsibly. The harness signifies a maturation of the AI development ecosystem.
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.